Hello everyone, welcome to KnowHow Webinars. As you know, this is an online platform for professional education and it is managed by Technobase. What we are here today for the, we'd like to introduce our experts. We call a program called Meet KnowHow Webinar Expert so that you understand the expert capabilities and competencies and what kind of topics they're presenting for the KnowHow webinar, what are the details on each webinar they're presenting. That's an objective of this program, and Meet KnowHow Webinar Experts. Okay, I'm introducing to you Dr. Joseph Marcinko. He's a principal scientist and president of the Polymer Synergies based in USA. He's my first expert invited for the KnowHow project. I can say I owe him a lot on this journey of this KnowHow webinars. Let me quickly introduce about Dr. Dr. Marcinko. He has more than 35 years experience, R&D in the research management and academic experience. His interest and expertise are mostly in the areas of the polyurethane chemistry, biopolymers, adhesion science, wood composites, polymer characterization, solid state NMR spectroscopy, and polymer structure proportionships. He's also an adjunct professor and a developer of industrial short courses related to the polyurethane and polymer chemistry, adhesion science, and industrial problem solving. He's also authored the 50+ peer-reviewed publications, has 18 patents and 2 patents in pending. This is an extensive experience. Actually, we're very glad to have Dr. Joe Marcinko as one of the experts to contribute to various webinars. His education journey in educational summaries, and he did a PhD at the University of Akron in 1992 in chemistry. These are the webinars presented by Dr. Joe Marcinko, and we discuss more on this in his own words, what's all about his webinars, and he has more than 14 webinars, so we will talk about it as we go on. Okay. So let's meet our expert, KnowHow Webinar expert, Dr. Joe Marcinko. Joe, welcome to the program.
Thank you, Param. It's nice to be here.
So the way we do this program is that we'll get to know more about you, more of your experiences, and thank you for the time today, and to give more information on you. Okay, let's get to the points that we discuss. Is the I think I'd like to address about your first about your company. Okay, can you talk about your company? Okay, what your services? I think your company, the Polymer Synergies. Let's to give some input on it, on the Polymer Synergies.
Sure. My company, Polymer Synergies, was started in the year 2000, and it was basically set up to give small and mid-sized companies the R&D that they needed if they didn't have in-house capabilities. Over the years, it's interesting that many of my customers, in fact, most of my customers, are large corporations, some of the largest corporations in the world that I do research for on a contract basis. I do technology development and R&D here in my laboratory in Mantua, New Jersey, which is near Philadelphia. And we cover a wide range of chemistries that we can cover, mainly in the polymer science area. We go from synthesis to physical testing and making of prototypes and samples and testing of those samples. My company is also associated with a number of universities that I go to for more extensive analysis. I work extensively with the University of Akron to do spectroscopy, University of Maine to use their Advanced Composites Center and their laboratory facilities for many of my projects. Again, I work with small and large companies, providing consulting services and research and product development services to those companies. Okay.
Can you share some your background on your education, and also before you starting the Polymer Synergies, your experience, professional experience, and share some light on it, please. Thank you.
Sure. Well, I've always been interested in science ever since I was a young child. I always wanted to be a scientist. And I went to an undergraduate college called King's College in northeastern Pennsylvania. and I got a bachelor's degree in both chemistry and biology, as well as a teaching certification. Teaching has always been something that I have enjoyed doing. And so I got my bachelor's degrees in biology and chemistry. I taught for a short period of time before I went into industry, and that's where I was introduced to polymers and polymer science. And I really enjoyed working with these materials, specifically with polyurethanes and epoxy and rubber compounds. And I decided to go to graduate school, and I went to Case Western Reserve University in Cleveland, Ohio, and I worked there for 4 years. And then I transferred to the University of Akron to complete my degree because there was some equipment at Akron that they didn't have at Case, and I was making a lot of use of it. And it was just easier for me to transfer to Akron to finish my degree. And so I got my master's at Case and my PhD at the University of Akron. After I finished graduate school, I worked for Dow Chemical for a period of time, and then I transferred jobs, and I went to work for ICI Polyurethanes. And ICI Polyurethanes was subsequently bought by Huntsman Corporation, became Huntsman Polyurethanes. And I worked there for 10 years. And I worked in the adhesion science group at Huntsman. And I led the wood composites and the adhesion science group at Huntsman for a number of years. And at the turn of the century, I always had a dream to start my company, Polymer Synergies. I even came up with the name Polymer Synergies back when I was in graduate school, and I decided it was a good time to start a new venture. And so I did. I left my job, I started Polymer Synergies, and I started working for a number of companies doing consulting and contract R&D work with those companies. And I'm happy to say that I'm in my 21st year of doing this. I'm in my laboratory for the same number of time, and it's been an excellent journey and a lot of fun.
Super, super. So it's good to be as an entrepreneur of your own, having your own business.
Yes, it's there's a lot of challenges to it, but there's also a lot of rewards. It gives me the freedom to work on a lot of different types of chemistry, something that I would not be able to do in a large company. In a large company, you're working within a group, and you're specializing in a certain area of chemistry. But here at Polymer Synergies, I'm free to take on projects of all kinds. I am a polymer physical chemist, somebody who characterizes polymers. That's what my background in education is. My dissertation in graduate school was structure property relationships in polyurethane elastomers. So when you're working in a company, you're focused on a certain area. Even though I'm a polymer physical chemist, I do organic synthesis in my lab when necessary for certain companies. That creates challenges because it's not an area of chemistry that I have a lot of expertise in, but it does allow me to learn new chemistries and get involved in new chemistries, and that keeps my job very, very interesting because I have different challenges with different customers and different products all the time.
Yes, that's nice. That's nice. You have 18 patents registered on your name now, and also a couple of more pending. So can you share some light on, about your patents and your active researcher, innovator? Okay, so let's can you talk about more about these patents and how many of them are commercialized, and also can you talk more on this?
Well, as you mentioned, I have 18 patents that have been assigned. I have 2 patents pending, and there's always the possibility for more patents, especially when you're working on research and development projects for yourself or for other companies. My first patent was granted in 1990, and it was for a company called Beloit Corporation. It was a polyurethane composite that I developed for them. My most recent patent is for a moisture barrier that can be used on concrete or wood composites. And so the variety of patents that I have, all revolve around some type of polymer science. Some of them are for synthesis. We're making hydrophobic, oleophobic coatings. Some are for adhesives. Some are for polyurethane foams. So they cover a wide variety of applications. Now, when you're patenting, it's not a one-man show. You're usually interacting with other people. Even though I have no other scientists in my lab, I do sometimes bring in other scientists as consultants to work with me and to work on projects together with me. And it's the combination of ideas that come from a number of different people when you're trying to solve a problem that the patent arises from. And so usually a patent has more than one person's name on it, especially in the type of research and chemistry that I do. One of the things that I do when I'm working with any company is I grant them the patent rights for any new invention that comes from the work that I'm doing for that company. That creates a very open working relationship with the companies that I'm working with, because they're not concerned about patent rights, because I upfront grant that to them. Of course, I would have to be an inventor on it. That's by law if I'm involved in inventing it. But I grant the patent rights to the company. And so that makes for a good working relationship with these companies, because that's something that's important to them. If they're going to invest in research, they want to make sure if any intellectual property comes from it, that they can capitalize on that intellectual property. So patents are, again, a collaborative effort, and I have a number of them. I have a number of them that will probably come in the future. It all depends on the project that you're working on. And a patent comes from solving a problem and coming up with a solution to that problem that is not obvious or known in the literature of patents or open literature that's reported in the scientific realm.
Is it how long it takes to get a patent get registered? Is it time consuming and it needs a lot of any funds for it? So that you can encourage others, innovators to, kind of guidelines for the younger generation who like to invent things.
Yeah, the getting of a patent is a very complex and time-consuming endeavor. First of all, you're doing the research, and then secondly, you're reporting on that research. And then you have to, if you're going to go for a patent, you have to understand how your invention fits in with what is already known. And so there's a lot of iteration with patent attorneys who are going to do some literature searching and sharing that information with you. And it's an iterative process where you are explaining to the patent attorney how your invention is different from what is being presented to you as a similar type of a patent. And so this iteration process goes back and forth. And once the patent is submitted to the patent office, it usually takes a year to 2 years before you get a response from the patent office on whether they will accept or reject the patent and the claims that are in it. And this is, again, another iterative process, because the patent office doesn't know intimately what you have done, and so you have to explain to them why your claims are valid over other claims and why they should be accepted. And so it's, again, an iterative process, and it can take anywhere from 2 to 3 years up to much longer than that to actually get a patent to be filed and to be accepted. So it's a long process that takes a lot of time and a lot of energy.
One of the your specialization is on the polyurethane adhesives. And what are the development, the technology trends that you see in these polyurethane adhesives, and your input on this?
Sure. Well, adhesion science is a fascinating area of science, because it combines chemistry and physics and engineering. And so it's very, very interesting. And polyurethanes make great adhesives. That's an area that I specialize in, isocyanate and polyurethane adhesives, although I've developed rubber compound adhesives and epoxy adhesives for various companies. When you're studying adhesion, you have to study the surfaces that you're bonding. You have to understand those surfaces. You have to make sure that you understand the environment that the adhesive needs to be used in. And so all of these factors come into play in designing the adhesive. Is it going to be used in a moisture-rich environment? Is it going to be used in a dry environment? What are the temperature and environmental conditions that the adhesive has to go through? Is it going to be a structural or a non-structural adhesive? All of these things come into play when you're designing an adhesive. And you have to think about adhesive design from a molecular perspective. You have to understand how the molecules move and how they work in conjunction with each other, their entanglements, their associations, because all of these contribute to the physical performance of the polymer of the adhesive and how it's going to work. And so you have to design adhesives from a molecular perspective, from an energy dissipation perspective, and from an application perspective. What are they expected to do? Are they expected to hold car bodies together? Are they expected to hold buildings up? Are they just going to be adhesives that are going to be used on Post-it note type of paper applications? They all have different requirements, and they're all stringent requirements. Even for a Post-it note adhesive, you have to have an adhesive that sticks but doesn't stick too hard. You have to have an adhesive that sticks to the surface but doesn't leave a residue on that surface. That all has to be designed into an adhesive. Another area of interest are bio-based adhesives, and bio-based adhesives are becoming more and more prevalent in our world. This creates challenges because the chemistry is different, so you have to reformulate based on those bio-based materials and polymers that you're using, and they don't often have the same performance and properties as petroleum-based adhesives. And so that's a new and growing area and an area of a lot of research, and it's an area that's a lot of fun because the source of raw materials is tremendous for bio-based materials.
Okay. You also have an expertise on the wood composites, right? And you work on extensively on the wood composites as well. Yep. Yes, what's happening in the what's happening on the wood composites currently? So can you share some light on this, on the wood composites?
Well, when I started working back with ICI, Polyurethanes, in the adhesion group, a big part of our adhesive customers were wood composites companies, companies that make oriented strand board, particle board, medium density and high density fiber boards, plywood, things like this. And again, when I talked about adhesion science being fascinating because it involves chemistry, physics, and engineering, when you go to wood composites, it also involves not only chemistry, physics, and engineering, but biology, because wood is a biological species. And it's a fascinating species, and I got hooked on it because wood is such an amazing material itself. It's a composite material on the molecular level, it's a composite material on the microscopic level, and it's a composite material on the macroscopic level. It's filled with all kinds of chemicals which contribute to its surface chemistry and energies. And all of these things have to be taken into account when you're designing an adhesive for a wood composite. How fast the adhesive cures, is it going to be a structural or a non-structural adhesive? And polyurethanes and isocyanates are great chemistries and materials to make adhesives for wood composites. And so I've, through my career, worked extensively with a lot of people in the wood composites industry. That industry is growing because everybody is looking for sustainability, and wood is a sustainable material because you can grow wood. And then you can also make it more sustainable from an environmental perspective because you can take wood that isn't structural. So you can take a rapidly growing tree that doesn't have a lot of structural integrity. You can chop it up into pieces and then you can reconstitute it into a wood composite that's much stronger than the wood itself. So that's what makes it so sustainable. And there's a big movement now for building materials with cross-laminated timber. And what that is cross-laminated timber is taking whole timber and gluing it together, all in the same direction, and in the next layer in the perpendicular direction, and gluing it all together, and using it now for high-rise buildings. So that creates a huge challenge if you're gluing wood together, and it's a lot different when you're making a structure that's 1 or 2 stories versus a structure that's 20 or 30 stories, and the performance that these components all have to have. And so that's a big challenge, and it's an exciting challenge, and it's one that I am doing research in, and it's very, very exciting. So wood is a fascinating material. You know, wood itself, a tree itself, cellulose is the most abundant polymer in the world. And of course, a tree is composed of cellulose along with other materials. And it is, you know, a fascinating material because as a tree grows, if it's growing out of the side of a hill, perhaps, what happens as it grows out of the side of the hill, it will start to grow upward towards the sunlight. So as it grows upward, this elbow part of the tree, as it's growing, knows that it needs to be stronger. And so the tree reinforces the wood there. It makes the wood denser at that elbow so that the tree can support the new direction that it's growing in. So it's a smart material because it can adjust its physical properties as needed. That makes it a fascinating material in and of itself. And then when you're trying to adhere to that material, it's very challenging and very interesting science and chemistry.
So it's fascinating. I think there's a lot of future there for the wood composites, I guess, right?
Yes, yes, it's a growing industry all around the world.
Yeah. Could we go to, I'd like to get some more information. You know, you have run the own business for many years, and so you'd like to share some milestones or, you know, successful outcomes from the polymer synergies.
Sure. You know, I'm very proud of my company, all the patents that have come out of it, and all of those patents are, I can happily say, are commercialized. You know, that's a big deal. A lot of times companies get patents just for the fact of protecting themselves against other competitors, but all of these patents are being used that I have developed, so I'm very proud of that. The challenges in my business and with companies now and is that a lot of major companies have minimized their R&D efforts. And this started back in the 1990s, and that's why I had the idea of starting my own company. And so the challenge exists of developing new products, but not having an understanding of those products. And that's where my company comes in, and I help them innovate and patent. One of the difficult parts of companies not having R&D is that they don't know how long it takes to develop a product. In fact, just this week, I had a company contact me they have a new polyol based on coal, and they would like to test this polyol for certain applications. They think it can be used in polyurethane foams for rigid foam, and they'd also like to test it for an adhesive, and they'd like me to start with the adhesive work. And so I outlined a project for them to propose what should be done, and it's just a brief project just to see whether it's possible to make an adhesive with this material. But the timeline is that I gave them is about 3 months for this work. And they said, no, that's much too long. We want an answer within 2 weeks. And I explained to them that you can't do that because, first of all, I have to logistically order chemicals and have chemicals arrive and set up my reactor to react these materials. That takes time. After the material is made, you want it tested. And to do the testing, we have to test for the particular type of tests. We have to test at a particular university to do this test. And we have to schedule with that university. In addition to getting on their schedule, We have to make the samples, and then the samples have to equilibrate after they're made for 2 weeks before they can be tested in the ASTM method that you're asking for. So it's impossible to give you an answer in 2 weeks because logistically it's just not possible. And people just don't understand how long it takes to design an experiment, to do the experiment, to analyze the data, to iterate on that experiment. That's a challenge that exists in our world today, but it also brings opportunities. You know, some of the successes that I've had are because I can get things done a lot faster than other companies, like big companies. I have some of the largest companies in the world that I work with, and they ask me to order chemicals for them, for their lab, and also to be used in my lab because of the process that it takes for them to get chemicals into their lab, and those chemicals have to be quarantined for weeks before they can be used in their lab, where I can order chemicals immediately, I can get them in a short period of time, I can start my experiments and do the experiments that I need. And that's a success, and that's what has allowed me to stay in business for the past 21 years, because I bring this. But the biggest successes that make me happy are the ones that are technical, that solve problems. For example, I had a customer that had an electronic component that was being adhered together with an adhesive, and they were having failure rates over 50%, well over 50% on a lot of their parts, and they didn't understand why, and they brought me in. And over a short period of time, we were able to analyze their process, do some characterization of their materials, and basically their materials were undercured, even though they were curing them the way the manufacturer of the adhesive told them to cure them. And we showed them that if they cure at a higher temperature for actually a shorter period of time, so the production would go up, their failure rate dropped to less than 5%, and they were very happy with that result. And those are the kinds of successes that you like to have to help people. Another success that I'm very proud of is the patents that we have on bio-based hybrid adhesives and polyurethanes. Those are being implemented now all over the world, and I'm very happy to say that you know, it's a sustainable chemistry that people are using.
Super, super. It's always difficult to convince the people with the objectives of research in expectation short time, I guess. Is it?
Yes, that's very, very difficult. There's not a good understanding of how long it takes to, you know, characterize, do research, do testing to get a new product out to market. It takes a lot of time.
Yeah. I want to get to the, you know, I'd like to ask you about, you've been associated with Technobiz for close to 10 years, I guess, now, and you've also active member of the KnowHow Webinars. So what is your interaction with the, you know, KnowHow Webinar project managed by Technobiz? What's your, you know, what's so far journey is like?
As you mentioned, I've been associated with Technobiz, who is the parent of KnowHow Webinars, for about 10 years now. It's been a great association. First of all, I love to teach, and Technobiz and KnowHow Webinars have allowed me to indulge my passion without going into the true academic world. Although I do teach as an adjunct professor at Akron University, I do enjoy teaching, and KnowHow Webinars and Technobiz allow me that opportunity to teach. When I'm teaching for Technobiz, I'm usually in an exhibition or conference someplace, and I'm either teaching one-day courses or a number of shorter courses over the period of a day. It allows me to interact with a lot of people from all over the world and get to know people all over the world and learn from them, as well as them learning from me. You know, learning is a lifelong process, and if you continue to do it, I believe you're happier and a better person. And so I do enjoy teaching and learning from all the new people that I meet when I travel for teaching for TechnoBiz. In addition to that, teaching via KnowHow Webinars has been a way for me to indulge my passion of teaching while travel has been limited due to the COVID-19 pandemic. And so it's bringing me together with people, again, from all over the world. I interact with those people and share with those people what I'm teaching on the particular topic, but I'm also learning what they need and what industry needs by their questions and by them interacting with me and sharing knowledge with me that I can help them move forward in some direction. So KnowHow Webinars has been great. Thank you, Param, for setting it up because it allows me to continue to teach, but it also allows people to learn from me and me to learn from them, and for information to continue to be shared. You know, knowledge doesn't mean anything or isn't worth anything unless it's shared with others. And, you know, KnowHow Webinars allows us to share our knowledge and to gain knowledge from others.
Well, I had to thank you a lot. You know, it's all started with you, the first webinar, and now we have close to 200 plus webinars on various issues, you know, working with 70 plus experts from different parts of the world. It's a real evolution, and, you know, thank you to you, you know, for suggesting me, guiding me in the beginnings, and yeah, it's a wonderful journey. Now the KnowHow Webinars give a chance to a lot of, not only the in the past, as you mentioned, that we did you know, at various physical events, we have a chance to meet people, but now KnowHow Webinars give us more broader and various regions people participate in our programs. It's a great, thank you very much, appreciate that. I've always said it's all because of Dr. Joe Marcinko. You know, it's a journey started with a KnowHow webinar.
Thank you.
I think, you know, it's a time to, for the benefit of the audience, I do ask you to, you know, share the, you have done quite a number of webinars for the KnowHow Webinars on various specific subjects. So we go one by one topic, you know, to explain what's the object of this webinar and what is included in that one, what audience benefit out of this topic. Probably be a few minutes on each, you know, on this subject. So let me just flip through the various webinars one by one. Yeah. Okay, the first one, yeah.
All right, moisture cured one component, reactive polyurethane adhesives. This webinar talks about how you develop and formulate these moisture cured adhesives. And all of my chemical lectures come from a structure property performance perspective. So I don't believe you can develop new products of any type unless you understand from a structural perspective, from a molecular architecture perspective, what the molecules are doing and how you put those molecules together to get the performances that you want. For this particular webinar talking about moisture cured adhesives, we talk about you know, what it takes to make a one component adhesive, from the chemistries that you put together to the catalysts that you use, to the polyols and isocyanates that you use for different types of applications, and then the synthesis and the manufacturing of these materials, and how you have to be very careful with moisture, moisture that may be in the fillers that you may be using in your adhesive, moisture within the polyols that you're using, because moisture will chew up isocyanate, and you won't get the type of materials that you are anticipating if there's too much moisture. In addition to that, since these are one component systems, they will react over time in the container that they're in if you don't control moisture. So we address all of these aspects from the molecular level to the manufacturing in this webinar on moisture cured one component adhesives. How polyol selection affects polyurethane performance. Again, I teach this from a structure property performance relationship, and I talk about the various types of polyols, polyether polyols, polyester polyols, natural polyols, the structure of those polyols, and how it affects performance. Okay, if you're using a polyester polyol in an application, you're going to get more hydrogen bonding. It's going to be a tougher type of material. If you are looking to create a material that's going to be used in a hot, wet environment, you're going to want to use a polyether polyol, and I explained the chemistry of why you want to use polyether polyols versus polyester polyols. Are you going to use a branched polyol, or are you going to use a linear polyol? And what are the advantages and disadvantages of these different types of polyols, and how you combine these different types of polyols together to get the actual performance that you need for the application. Next one. Wood adhesion, isocyanate, and polyurethane adhesives. As I mentioned earlier, wood is a fascinating material. It's a fascinating material on its own, but it's also a fascinating material to bond to. And this particular webinar talks about adhesion mechanisms and how isocyanates and polyurethane adhesives interact with the surfaces of wood, with the chemistry of the wood, and the types of interactions that you get forming various types of bonds that can be characterized in different ways. We talk about this adhesion mechanism. Are we getting chemical bonding, or are we getting physical bonding, or are we getting a combination of these types of bonds? This is all presented in this wood adhesion webinar. Structure property relationships in polyurethanes. This is, again, something that's a part of me. This is where I started. This is what my graduate research was about. Back when I was a young man that had hair, I studied polyurethanes and developed structure property relationships of polyurethanes to get my understanding. And polyurethanes are fascinating materials, okay, because they're copolymers. They're made in a unique way. Unlike polyethylene or polystyrene that start from an ethylene or a styrene monomer and that are polymerized and polymerize rapidly, polyurethanes start with isocyanates, there are various types, and polyols, which there are even more types of, and you can put them together in a variety of different ways. And that will give you a variety of different properties and performances for those polyurethane polymers. And that's what this webinar is about. Understanding how you put the molecules together to get the performance that you want, and how that performance is usable in various applications. Isocyanates and how they're made. This, like the polyol webinar, is to get at the fundamental materials of polyurethanes. I think it's important that people understand the materials that they're using and how they're made. And if you're buying a material, an isocyanate like polymeric MDI from Huntsman Corporation, is Huntsman's different than BASF's or Wanhwa's or Covestro's isocyanates? And so what we talk about is how isocyanates are made, how companies make them, what are the specific chemical processes that are involved, what are the side reactions that occur, what are the byproducts that might be in your isocyanates. So this is to get an understanding of your raw materials that you're using if you're making a polyurethane. Polyurethane adhesives, sealants, and binders. This webinar talks about the difference between an adhesive, a sealant, and a binder, okay? A binder is a less formulated adhesive. A sealant, by definition, is a gap-filling product that has a certain viscosity that can fill gaps. All of these are designed to behave and perform in the way that you want. So again, we approach the development of polyurethane adhesives, sealants, and binders from a structure property performance relationship, and we talk about what's necessary to get that performance. Okay, molecular weights are important. If you're making sealants and some adhesives, there will be various types of additives or fillers that you might want to use in them. and how we put these things together, and the pitfalls and the positive nature of doing certain things are all addressed in talking about these types of adhesives, sealants, and binders in this webinar. Understanding the viscoelasticity of polyurethanes. Well, all polymeric materials are viscoelastic. What is viscoelasticity? Okay, viscoelasticity is that the polymer behaves like a viscous liquid under certain conditions, and it behaves like a spring, an elastic spring, under other conditions. And how do you get viscoelasticity? And what is viscoelasticity, and how does it contribute to the performance of your polymers? So this is a webinar that talks about the fundamental nature, the fundamental physics and the chemistry that leads to viscoelasticity, and how this viscoelasticity affects the performance of materials like polyurethanes. It's an area of more fundamental understanding, but it's a very, very important understanding that you have to have for materials. I mean, one of the characteristics of a viscoelastic material is that when it rubs against another surface, there's friction, okay? That's why your tires make your car roll, because of the viscoelastic properties of the rubber, okay, is an example. So understanding viscoelasticity is really an important thing. And you can design the viscoelastic properties in a polyurethane polymer by how you put them together. Understanding polyurethane catalysts and how they work. Well, polyurethane catalysts are a part of polyurethane chemistry, both in the synthesis part of it, but also they can be used, as we talked about, in moisture cure adhesives. So what is a catalyst, and how does a catalyst work, and what kind of catalysts are there, and which catalyst should you use for certain types of chemical reactions that you're trying to promote to make go easier? Remember, a catalyst makes a reaction proceed more easily by lowering the activation energy of the activated complex that's formed. And so we talk about that activated complex, and we talk about how the catalyst interacts with the isocyanate molecules, with the polyol molecules, or with both of those molecules simultaneously in this particular webinar. And it's to help you understand how to formulate with your catalysts. Just as with the catalyst webinar, understanding the use of surfactants in polyurethane formulations is important as well. Surfactants provide a lot of different functions in polyurethanes. They not only are used to stabilize bubbles in making polyurethane foams, whether they be rigid foams or flexible foams or molded foams, but they also are used to compatibilize your isocyanates and your polyols, because if you're making a flexible foam, for example, you're probably using an aromatic isocyanate like TDI or MDI, and you're using a polyether polyol. That's aliphatic. Well, you remember from your basic chemistry that aliphatics and aromatics don't necessarily like each other, and they're not compatible with each other. What the surfactant does is helps bring those together, and if you bring molecules together, they can react. So in this particular webinar, we talk about the use of surfactants and the types of surfactants and where you use them, and how you use different kinds of surfactants and different quantities of surfactants for different types of polyurethanes. Differential scanning calorimetry, applications and relationships in polymer processing. I'm a polymer characterization chemist. That's how I get my structure property background and understanding of materials. Differential scanning calorimetry is a powerful tool for looking at materials, and not only for polyurethanes, but for all materials, because materials will have melting points, they'll have crystallization points, they'll have glass transition temperatures, and these can be measured via DSC. And understanding these transitions can help you in polymer processing. So if you're extruding a polymer, understanding what the melt point of the polymer is, or any glass transitions that might be in this polymer, if it's some type of a polymer mix, is something that you can use DSC with to help you understand how to process that polymer as you're scaling it up through an extrusion process, for example. In addition, you can use DSC to study kinetics of reactions, and this is important also. I mentioned that I looked at the cure kinetics for a company that was having a lot of failures in their adhesive parts, and we used DSC to do kinetic studies on their adhesive and show them that their adhesive needs to be cured in a different way. And DSC was a big part of that study. And so it can help with polymer processing, and that's what this webinar is all about. Dynamic mechanical analysis in applications and relationships in polymer processing. Just as I mentioned for DSC, we can use DMA in the same way. Dynamic mechanical analysis is a very, very powerful tool. It's where you're oscillating your sample in some way, either stretching it or bending it or torquing it using a sinusoidal perturbation. And you're looking at the viscoelastic response of that polymer due to that sinusoidal perturbation. This gives you information about the energy that's stored in the molecule or in the polymer, the energy that's dissipated in the form of heat as a viscous response in that polymer. And these are related again to polymer processing, certainly to extrusion applications, certainly to hot pressing applications. This is very, very important, not only for the polymer processing, but also for the end performance of the polymer and helping design that material. And you can use DMA to understand your formulation. So as you formulate, you can look at is the component that you put into your formulation to give you toughening, giving you a response in the temperature range that you need, and how will it respond as you process this polymer in some way. That's what this webinar is all about. DMA is a very powerful characterization tool. Solid-state nuclear magnetic resonance spectroscopy, applications and relationships in polymer processing. Well, I told you about the DSC webinar and the DMA webinar. This webinar is very similar. What solid-state NMR allows you to do is look at a polymer in its natural state, its solid state. But unlike DMA, that's looking at bulk performance, okay, of the polymer, what solid-state NMR allows you to do is go down to the atomic level, to the molecular level, and look at the nuclei of specific parts of the molecule and how they're moving and relaxing. Now, why is this powerful and why is this important? Because not only do you get a fingerprint when you take an NMR spectrum, because it's a spectroscopic technique, but you can measure the relaxation rates of the molecules and how they move. And this is where true structure property performance relationships come true. If I can do a DMA scan on a polymer, and I can do solid state NMR on that polymer at variable temperatures and look at what parts of the molecules are moving at what time. Now I know the molecular signature that's giving me the DMA thermogram pattern or transition that I'm looking at. And I know that that transition that I'm seeing in the DMA relates to rubber toughening, relates to toughening of a polymer in its application. So this is showing a true structure property performance relationship. And when you have this type of powerful understanding, now you can design molecular architectures to give you the performance that you want. And that's why we use solid state NMR and combine it with things like DMA and DSC and other thermal analytical techniques to give us this application relationships that we get for polymer processing. Thermal analysis of polymers. Thermal analysis combines all of these techniques that I talked about. It'll combine variable temperature solid state NMR. It'll encompasses dynamic mechanical analysis, differential scanning calorimetry, rheometry, thermomechanical analysis. Thermal analysis of polymers is a fascinating area of study, but it's also very important because as the previous webinars that we talked about stated, they are very applicable when you use thermal analytical techniques to processing of materials and polymers and to understand the performance and behavior of those polymers. So this particular webinar covers all of the techniques and how they can be used, but it also talks about some experimental considerations that are very important, because if you're going to do an experiment, you have to make sure that the data that you're going to get is very good. And so we talk about the importance of setting up the experiment and the things to look for when you're setting up and designing an experiment, and the parameters that have to be paid close attention to make sure that you get good data. And that's what this webinar is all about. I teach a class known as a master class on polyurethane chemistry. And this is a full day class. It's sometimes broken up into 2 half days, but it's an extensive class that talks about all aspects of polyurethane. It talks about isocyanates, it talks about polyols, it talks about how those isocyanates are made, how the polyols are made. It encompasses catalysts and surfactants, but we also get into fundamental polymer science and how polyurethanes are different from other types of polymers, like polyethylene, for example, and how they're similar. We talk about molecular architecture and branching. We talk about molecular entanglements. We also talk about the thermal analytical techniques to be used in understanding your polymer science. It combines every aspect of polymer chemistry and the characterization of polymers, of polyurethane polymers, from a structure, property, performance relationship, all in a one-day class.
Okay, thank you, Joe. It's for explaining various content of all the webinars that you have for the KnowHow webinars. I'd like to ask you whether I'd like to invite you to share welcome message to the global audience about inviting them to join your webinars on regular basis through the KnowHow webinar platform. Thanks.
Okay. Well, first of all, I want to thank all of the people that have participated in my webinars thus far. And I want to thank you, Param, for providing this forum for me to be able to teach, which is one of my passions. I encourage you to interact with KnowHow Webinars and TechnoBiz. I encourage the global materials world to interact with KnowHow Webinars, because they provide a variety of aspects. My chemistries that I talk about, adhesion and polyurethane chemistry, is just a small part of what KnowHow Webinars and TechnoBiz provide. So the world is open, and it's a great way to learn about other technologies and chemistries besides the one specific chemistry that you might be interested in attending my particular webinars or classes. As I said, I teach because knowledge serves no purpose unless you share it. I love to share what I know. I will tell you what I don't know as much as what I know when I'm teaching. I don't know everything, but if I don't know something, I will try to find that information out for the students in my class, and I will connect with them directly. They can reach out to me via phone or via email, and I interact with all of my students in my classes like that whenever they need help. I help people with their projects after my classes if they're interested in that on a consulting basis, or if they just have a question and that they don't understand, they can contact me at any time. So TechnoBiz and KnowHow Webinars is a conduit to me in getting information from me, but it's also a way of sharing information with a lot of different people in a lot of different ways. And so KnowHow Webinars and TechnoBiz in general is a way that you can get in touch with me. Of course, you can get in touch with me directly. You can find me at polymersynergies.com, but if you want to interact with Param or get in touch with me through Param and TechnoBiz and KnowHow, please feel free to do that. I'm happy to share any information that I can. And also, I will say if there are any people who have any ideas or want a specific webinar that I haven't given, please suggest it to Param, and I will see if I have the knowledge to present that. If I don't, I may know somebody who does, and I will share that knowledge with Param so that he can have that person prepare that webinar.
Thank you very much, Joe. I really appreciate, and it's a really interesting journey together with the Technobase and Dr. Joe Marcinko. I'm hoping that we reach out to the global industry, particularly the polyurethane side, to educate, empower them through KnowHow Webinars project. And thank you. Before we end this session, maybe I quickly introduce about the KnowHow Webinars. How people can be participate. Can be the member. What are the benefits to being a member? And so let me quickly glimpse through the all the information about being memberships. So first of all, see, we offer the specialized professional education programs with the global experts and focusing on the current needs and the trends. It's important that you need to update yourself, and also we KnowHow Webinars gives us that opportunity. And one believes, just like as Dr. Joe mentioned about learning, we focus on the quality learning. It's all about quality. So people like Joe Marcinko, well experienced, they're willing to share and empower people. And so we are really fortunate work associating with experts like Dr. Joe Marcinko. They have a knowledge, they have expertise, and they're willing to share. That's a perfect combination. That's what all about KnowHow Webinar. All our experts are that structure we have with them association. Okay, you can see these are the experts. All of them. They're from the different parts of the world. They're well experienced and highly knowledgeable. And it started with Joe as one for the KnowHow Webinar, but I worked with them in the past, many people. But now it's the tree, with the family tree is growing. And again, I say the seed started with Joe, but it's really transferred itself with working with more than 70 plus experts now, and there more will be coming in the near future. So it's a great journey. And if you're interested in any of the topics that, what topics we have, I encourage you to check, the knowhow-webinars.com. It's not just only polyurethane, we also have the rubber, we have on the plastics, we have on chemical engineering. We're focusing on the industry and, technology aspects and up to date with global experts. Okay. We have memberships. I encourage you to be a member. Okay. Basically, that way you benefit a lot from our membership. So we have 5 types of the memberships. Professional member, it's basically for the individual. Corporate member is for the companies, so they can utilize this membership to train their staff, their team, and also we have education student members, which are big focusing for the universities and colleges. They use these educational tools to train the students, researchers or postdocs, whichever way they can utilize. And we have an additional premium scale where you get more benefit being a professional member and a corporate member as premium. Okay, just give you some glimpse of the prices and benefits. Being a professional member, you get $500 per year. You get regular discount registration fee, and also these are the benefits. I can send you the more if you need more information on these benefits and privileges. Okay, corporate member we charge $1,000 per year. Education student member is $2,500 per year. It's basically for the universities and colleges. Okay, there are certain conditions and terms will be there for utilizing our platform. Being a professional premium member, you have full access to all the topics what we available to the KnowHow Webinars, and also associated with our experts. And the same thing with the corporate member as well. Okay, so premium corporate member. And brand membership, this is something we added recently. Sometimes the companies, they want to educate their customers At the same time, they also want to utilize this platform to introduce their technologies and products. So if a company is interested to utilize a know-how platform, education plus corporate branding, it works well. So we also have that membership opportunities also there. So please check our website, and if you want to be a member, this is our website link where you can register. Okay, remember. Okay, so that's briefly about it. And this is a way. My name is Peram Prasadara. I started this one with, but all the credit goes to the number of people around me, and one of people like Dr. Joe. There's so many people involved in my journey. I'm thankful for all these people. So reach out to me if you have any questions, comments on, so. Okay, that's that's the end of the today's session of the Meet Know-How Webinar Experts. So before we end, I will ask Joe, any final remarks, for the audience who will be seeing this this program today. Yeah, thank you.
Yes, well, I just want to thank again anybody who is watching, and please feel free to reach out to me if you have any questions. Or would like any help with a particular project. You can reach out to me directly or through KnowHow Webinars or TechnoBiz. I appreciate your time and your attention. And also, if I can be of any help, I'm very happy to help people solve their problems and work with you and get to know how we can make this mutually beneficial for both of us to gain knowledge and to solve problems. With that, I thank you all for your time and attention.
Thank you, Joe. Guys, thank you all for joining this session, and I'm hoping that you learn more about our experts, why you had to be participate in our know-how project. If you're if you're watching this webinar, if it's session, you are an expert. The door is open to work with us. Okay, so please write to me, reach out to me. So thank you all. Let's be the part of the technology journey. Bye bye for now. See you later.